Okay, see here, Gayatri, listen, how you are to talk, students, see here, you have to log into the username student XX. The number is actually 21, 22, 23, 24, 25. And then the IP, the host name is cerberus.nic.uoregon.edu. And then you have to go log into the Silicon system. It's a server which is connected with multiple FPGAs as well as the GDS2, the complete the open PDK. And now we are going to start the lab. Before that, I recommend everyone need to open up the GitHub repository and all the stuff. I hope people are not actually on the mobile phone. If you are not on mobile phone, you can't do any lab here. So mobile, you got to be using a laptop or a desktop, so that you can very well move on to this lab. So Gayatri, now you can now open up that GitHub thing, the other GitHub introduction to GitHub. Yeah, can you? Okay, can you slideshow it?
Yeah. So for with Microwatt, we need to register into GitHub. So for that,
No, it's still not audible, Gayatri. It's not audible.
for creative, for working with the cloning with Microwatt, we need to register into the create an account with GitHub. So first we need to go for this creating a GitHub account, where you'll find what is the GitHub. You can we'll say like it's a code hosting platform where we'll do the version different type of FPGA in cloud we will work, and it is a collaboration of different repository where different one person is using the repository that is free for another some other person to use it, and it will be in cloud, so you can use that repository for your design. So this is the process where you can open a GitHub account. So click on this link where I'm showing in the screen, and enter the details of whatever the person details, username and all. Then so the what capture your persons will be there. You enter it and create an account. So after creating an account, the GitHub will send you an email, and so confirming that you have you received the email, and then you will click on that email, and you'll get the you'll directly go to that GitHub account. From there you can create you see in the right corner over there, there is a drop down a new repository. From the in that you have first you have we need to then we are going to creating a repository. First create a repository. In that you have a when we memorize that name, what's the repository you are creating. So then after that creating, you give the description for what you are going to use, and then it will show you the details of repository whatever we have created. Then click on create, then it will create the repository. What is a fork of repository? Is like it will allow you to do the different your experiment, and it will allow the whatever the cloud repository what is we have created or other person has created, you can clone it and use that repository in your project. Here first we learn like their simulating whatever the RTL to SD we did like GD to their design how we have going for that we are doing like synthesizing the design, creating a design, and then synthesizing and implementing, and then simulating the design with our with hardware. Like if you work on Vivado, we used to do like that. that. But here what we do in GitHub, we are like without hardware we can create that one simulation, and for that we need to create a microwatt cloning. In that first we need system requirements are there, like Linux system, and you have to have like you Ubuntu, whatever the latest version is installed, and Vivado Vivado tool also to be installed. Then we'll create a build micro Python. They like we learn there in Devati madam was talking. We can do the coding through C or Python or something. So we'll have here we'll create a micro Python code. So in that this is the process where you can build a micro Python. So you can this steps you can do it in your Ubuntu, and in that Linux in command prompt you can in that terminal you can type all this one by one. Then you create a Power PC of different PT, and then we have to build the microwatt. So in that GitHub we have to clone this. If you give that link, then it will create the CD and microwatt. Then it will make it is a microwatt builder. It will build a microwatt. Then in that we need, if you are working in Linux microwatt, then this steps we have to build the root, and the root will be it will link with PPC64LL microwatt, and then it will be configure the process and it will install in your FPG board. So we build the Linux kernel. We have to be a processor, then where we'll store this all the details. So the architecture we have to do in the Power PC with the Power PC of microwatt. So in that we have to configure the details and compile it. Like before doing any process, we have to compile the project design. So we have to compile it, and by giving the instruction here, and then we'll get the architecture of Power PC, where we can put the microwatt, and we'll take image of our chip design. And there is a like if for that we are like system on chip. What is the design we are going to do? So for that we need to use it to build the target, like some physically. If you see, this is we are doing without the hardware. So this is so where physically we will use R3 A700 microwatt. So that details we will enter here, and this it will build a microwatt um, with our R3, whatever the type of FPGA you are going to use it. So this is the instruction to build the SoC. Thank you. And create like this type of GitHub account, and then we'll work for this silicon server in that. We'll work for that later.